In the endless motion of our planet, the ground beneath our feet is never still. Deep under the Pacific Ocean, immense slabs of the Earth's crust shift, grind, and press against each other, building invisible tension that one day must be released. For most of us, that reality feels distant, until the day the ground begins to move. In the imagination of scientists and disaster planners, few nightmares loom larger than a giant earthquake along California's San Andreas Fault, the line that splits the state in two and defines much of its history of fear and resilience. Yet, farther north, another fault lurks in the cold waters of the Pacific Northwest, a far more silent, but perhaps even more dangerous one. It's called the Cascadia Subduction Zone, and its next rupture could be the single most devastating natural disaster in North American history. For years, experts have warned that when Cascadia finally snaps, it could unleash what's been nicknamed the really big one. A magnitude 9 or greater earthquake, followed by a towering tsunami, could wipe out entire towns along the coastlines of Oregon, Washington, and British Columbia. But now, a new study adds an even darker possibility. What if Cascadia's collapse could also trigger California's San Andreas Fault? What if one really big one was followed by another? That's the question at the heart of new research led by Dr. Chris Goldfinger, a geologist from Oregon State University. Goldfinger has spent decades mapping the hidden scars of ancient earthquakes buried beneath the ocean floor. His team's latest findings, published in the journal Geosphere, suggest that massive Cascadia earthquakes of the past have been followed, sometimes almost immediately, by powerful quakes on the San Andreas. If that's true, then the two faults, though hundreds of kilometers apart, might share a geological connection, one capable of setting off chain reactions across the western edge of the continent. To understand why that matters, you need to picture how these faults work. The Cascadia Subduction Zone is where the Juan de Fuca Plate, a small slab of oceanic crust, slides beneath the edge of the North American plate. It's a slow process, just a few centimeters each year, but the friction between them traps energy for centuries. When that friction gives way, the entire edge of the continent lurches westward in a matter of minutes. The shaking lasts for 5, sometimes 10 minutes straight. Then, the seafloor heaves upward, displacing billions of tons of water and launching a tsunami across the Pacific. This is not a movie scenario, it has happened before, the last time in the year 1700, when the quake tsunami was recorded as far away as Japan. Goldfinger has spent much of his career studying the sediments that record these ancient events. In 1999, he and his crew set out on a research expedition off the Oregon coast. Their goal was to collect sediment cores from the seabed, long cylinders of mud and sand that serve as geological time capsules. Each layer tells a story, a quiet century here, a violent quake there. But during that expedition, a simple navigational mistake would lead to a discovery that changed how scientists view the West Coast's seismic risks. One night, a graduate student on the night shift entered the wrong waypoint into the ship's navigation system. By dawn, Goldfinger awoke to find the ship hundreds of kilometers south of its intended course, nearly halfway to San Francisco, right over the northern tip of the San Andreas Fault. He was stunned. But rather than waste the opportunity, he decided to take a few extra samples anyway. When they returned to the lab, the team analyzed what they'd collected. They were looking for turbidites, layers of sediment left behind by underwater landslides triggered by earthquakes. These layers usually form a clear pattern, heavier sand at the bottom, lighter mud on top. But the samples from that unintended San Andreas site looked strange. The layers seemed upside down. The heavy sand sat on top, while the fine mud rested below.